Hey everyone, ever stare at a math function and just wonder what numbers can I even plug into this thing? Well, that's exactly what we're going to master today, finding the domain. It might sound a little intimidating, but trust me, we're going to build a super simple toolkit that will have you solving these problems like a pro. Let's jump in. So this is it. This is the big question. You can think of it like this. For any function, what are the rules of the game? What are the valid moves you're allowed to make with your x value? The answer to that question is the domain. And here's the more, textbook definition. But that word defined is everything. We're on a hunt for all the x values that don't break the function, that don't give us some kind of mathematical error. It's the official rulebook for that specific function. Okay, so here's our game plan. We'll start super simple, then we'll add our first big rule for fractions. After that, we'll get our second rule for square roots. Then comes the fun part. We'll see how to use them together. And finally, we'll wrap it all up in your complete domain toolkit. First things first, the default setting. So what happens when there are no obvious traps? What's the domain for a function that doesn't have any fractions or any square roots to worry about? Well, this is the easy part. Just take a look at these guys. We've got a line, a parabola, a cubic. These are all called polynomials. And what do they all have in common? No fractions and no square roots. And because of that, our job is incredibly simple. That's it. For any of these polynomial functions, you can plug in absolutely any real number you can think of. Positive, negative, zero, decimals, whatever. And you will always get a real defined answer. So remember, no fractions, no square roots. The domain is all real numbers. That's a quick win. All right, let's level up. Time to add the first major tool to our kit. Things start to get way more interesting as soon as we introduce fractions, or what we call rational functions. This is pretty much the one and only commandment when it comes to fractions in math. You just can't do it. Dividing by zero is undefined. So any x value that makes the bottom of our fraction turn into zero is automatically kicked out of the domain. That's our only job here. So how do we actually find those forbidden values? It's the same simple three-step recipe every time. You grab just the denominator, you set up an equation that says this cannot equal zero, and then you just solve for x. Let's see it in action. Okay, check out this example. Now, the absolute first thing to realize is that for finding the domain, the top of the fraction, the numerator, does not matter at all. We can completely ignore it. Our entire focus is on that denominator. We need to figure out what values of x would make x squared minus 9x plus 20 equal to 0. And to solve this, we just factor it. So we're looking for two numbers that multiply to positive 20 and add up to negative 9. And that's got to be negative 4 and negative 5. This tells us everything. If x were 4, or if x were 5, we'd be dividing by 0. So those two numbers, 4 and 5, are the only ones not allowed. The domain is everything else. Okay, toolkit's looking good. We've got our fraction tool. Now it's time to add our second and final major rule, which handles that other common problem child in functions, the square root. And the rule is actually pretty straightforward. In the world of real numbers, you just can't take the square root of a negative. It doesn't work. So whatever is living inside that square root symbol has to be either 0 or something positive. In other words, greater than or equal to 0. Now when things get a little more complex inside that root, we just follow this process. We find the critical points where the expression equals 0, we put those on a number line, and then we just test a number from each section. If a section gives us a positive result, then that whole section is part of our domain. All right, you ready? Let's go to the final boss level. What happens when a function throws both at you at once? A fraction that also has square roots. This is where having our toolkit really pays off. Now this is a really important distinction. If a square root is on top of a fraction, the stuff inside is allowed to be 0. The square root of 0 is just 0, no problem. But if that square root is in the denominator, it cannot be 0 because that would violate our number one rule, no dividing by 0. So for a root on the bottom, the inside has to be strictly greater than 0. So here it is, our final challenge. We've got a square root on the top and a square root on the bottom. This means we have to make sure both rules are satisfied at the very same time. Let's break it down piece by piece. So first up, the numerator. We need x plus 3 to be greater than or equal to 0. Simple enough. That means x has to be greater than or equal to negative 3. Okay, part 1 is done. Now for the denominator. Here, x squared minus 16 must be strictly greater than 0.
When you solve that inequality, you find that x has to be less than -4 or greater than +4.
Okay, and this is the most important part. We have our condition from the top, and we have our condition from the bottom. The final domain isn't one or the other. It's the numbers where both of these things are true simultaneously. We need to find the overlap, the intersection. So just picture a number line. The first rule says we have to be to the right of -3. The second rule says we have to be to the left of -4 or to the right of +4. So what's the only region that satisfies both of those conditions? It's all the numbers strictly greater than 4. And that is our final answer. Wow, we have covered a ton of ground, from the absolute basics all the way to some pretty tricky problems. So let's put it all together. Here is everything we've learned all in one place. And there it is, your complete domain-finding cheat sheet. If it's a simple polynomial, you're good. It's all real numbers. If you see a fraction, just make sure the bottom isn't 0. If you see a square root, make sure the inside is 0 or positive. And for that special combo of a square root on the bottom, the inside has to be strictly positive. This table right here is your entire toolkit. So now you have the tools to figure out the allowed inputs for pretty much any function they can throw at you. But it kind of begs another question, doesn't it? If we know what we can put in, what does that tell us about all the possible answers we can get out? Well, my friends, that is a whole other concept called the range, and that's a story for another time. Thanks for joining me.